Lesson 10, the quotient rule. Okay, so in this lesson, we're going to be doing, well, kind of the next logical step, right? We did the product rule in the last one. Now we're going to be wanting to do the quotient rule for when we divide two different functions, right? How we can find the derivative of that. So we can develop a rule. There's one part that's going to require a bit of a leap of faith here that we haven't quite learned it, but just trust me on it. But what we'll do, we'll rewrite this first. So I'll say f of x is equal to, and then little f of x. And then I'm going to change this to times g of x to the -1, right? Just so we're kind of writing it in a row like that. And now what we can do is we can do the product rule, right? So we can actually multiply these guys. And that will actually be true for lots when we go down and we start doing more of these quotient rules. You can change it in this form if you like, right? There's lots of ways to do it. So let's write this thing out now as the derivative. So we'll say, okay, f prime of x, right? The derivative of x, or of f, would be equal to, and then just writing it out in our quotient rule form. I'm going to drop the x's for a second. Let's just call it f and g, just to kind of make my life a little bit easier. And we'll say this is f times g to the -1 prime, right? The derivative of that, plus, and then f prime times g to the -1. Now writing this out a little more, this would become f, and now here's the leap of faith part that we have to do. Well, let's take the derivative of this, right? This part will make sense. So we'd say that this was -1 and then g to the -2, right? Just taking the simple derivative of that part of it. But then we also have to multiply by the derivative of g again. And that's going to come up, and it's because we're taking derivative of f and g at the same time. This is going to come up a lot more in implicit differentiation, is what it's called later on, and the chain rule in the next lesson. But for now, just trust me that was the case, okay? So then the second part, this will all make sense now. So plus f prime times, and then just writing this again, g to the -1. And now let's just handle the negative exponents, right? We'll put them in the denominators. So this would become -f, and then g prime still up in the top with the derivative, over g squared, plus f prime over g. Just bringing that one down. And then what we can do now is let's put this over a common denominator, right? So I'm just going to multiply this side by g over g. So our new equation becomes -f times g prime over g squared plus f prime times g over g squared. And now I will just put it all over that common denominator. And that would be -fg prime plus fg, or f prime g, over g squared. And that's pretty much it. That is our quotient rule right there. So if f and g are differentiable, right? So we have to make sure that we can take the derivative. So again, no sharp points or dividing by 0 or any of those things. Then so is the quotient, right? So we can take the derivative of that. So then it might be written in this form now, right? With the x's kind of back in there. All right. Now a little way to remember it: low d high minus high d low. So low just means like the one in the denominator, right? The derivative of the one in the denominator. Sorry, I mean the other way around there. Low, and then the derivative of the high one, right? So low, and then the derivative of the high one, minus, and then high, so f, times the derivative of the low one, so g. I don't know if that helps. You have it on your formula sheet if you want, but and then draw a line and square below just means square the bottom one. All right. So let's differentiate this. So okay, so let's write down our formula just to have it on hand here. So we'll say f over g prime is equal to, and then it would be f prime times g minus f times g prime, all over g squared. And we'll just even write it right on here that this is our f, right, the top, and this is our g. Okay, so just one at a time here. So this would be, so f prime would be 2x, and just 2x, right? Bring the 2 down, and then the 5 would become 0, so that's just 2x. And then g would be 2x plus 1 minus, and then moving on to this part, so then f would be x squared plus 5. And then g would be just 2. All right, again, so just bringing the 1 down, becoming a 0, so that would just become just the number 2. All right, and then just all over g squared. So that'd be 2x minus 1, and then squared. So now, the good news is, too, this actually is the derivative, right? Everything we just did there would give you the derivative. So if it said, what's the slope at, f prime of 2, you say like f prime of 2, you'd actually be good to go there. You could throw 2 in for all the x's, and you should end up getting the slope out of that, right? But typically, we don't want to leave it this way, right? That's a little messy. I think we can do better than that, right? So let's expand everything out a little bit nicer here. So we'll expand this out and yeah, go from there. So this would become 4x squared and then plus 2x. Okay, and then I'm going to assume, just in my mind here, this was like 2 out front, right? And it'll just make it easier to distribute the negative 2. You guys are good at this, though. Do whatever method you were going to do there. So then minus 2x squared minus 10 all over 2x minus 1 squared. And then we'll just collect any like terms that we have on the top here. So this will be 2x squared minus, nope, plus 2x minus 10. And then that is all over 2x minus 1 squared. Now, if you can, just like what we did like in the radicals unit, like in last year and the year before, you want to see if you could cancel anything, because potentially I could factor a 2 out of the top here, and maybe that would cancel with one of my 2x minus 1s, right? So let's see what we got just to make sure. So we'll factor a 2 out, so we'd have 2, and then x squared plus x minus 5. So no, didn't really work out there, but over 2x minus 1 squared. And that's really it. That would be your derivative, okay? Now, let's before we go any farther, let's think about like when it would be useful to even use this method, right? Did you guys notice in this one that we kind of had to, right? Because, let's say the question would have been x squared plus 5 over x, right? Now, that actually probably wouldn't be a great place to use this, because if you've noticed, this all gets pretty messy, right? When you start typing, like you start putting in all of these different factors, right? Like in this situation below, I think what I would have done was just divide them both by x, right? So I would have called that x squared divided by x would be x plus, and then that'd be like 5 over x. And then you could rewrite that as x plus 5x to the negative 1. And then, man, that would be easy to take the derivative, right? You just take the derivative of this, take the derivative of this, and you're done, right? We weren't able to do that on this one because it was a binomial and a binomial, right? So just choose when you think it'd be the best time to do it. You don't, like, you could do it all the time, right? You could do it for this situation as well, but it gets messier than it should, okay? So, oh, before we get going, though, let's figure out what the domain of that was, right? Because it's only where it's differentiable. So the domain here, we can say, well, on the original f of x, then it would be x such that x is, well, just really not equal to negative a half, right? And that just comes from here, just when we were dividing by 2x minus 1. So you can see that that's my restriction on the derivative, but it was really also my restriction on the original as well, that 2x minus 1. Okay, so x couldn't be equal to negative a half, where x is a member of the real numbers. Okay, and then you could really say the same thing for the derivative, just exactly the same. X such that x cannot equal negative a half, where x is a member of the real numbers. All right. Okay, so let's do it again. So right off the bat here, I'm not a big fan of the radical symbol. Let's change that to an exponent. So I'm going to rewrite this as f of x is equal to x to the 1/2 minus 1 over x minus 3. Okay? And then again, this will be my f, and this will be my g. Okay? So let's take the derivative. So we'll say f prime of x is equal to, and then I'll write it as, so it'll be x minus 3, so g, right, just g, times the derivative of f. So that would be 1/2 x to the negative 1/2. Okay, so that would be my f prime. And I think I'm doing this like the other way around, right, than I did above. I had f prime and then g, but that doesn't matter, does it? So, okay, and then minus, so then it would be just f. So that would just be writing out x to the 1/2 minus 1. All right, that was my f. And then g prime, right? So then that would just be, well, what's the derivative of x minus 3? Well, that's just 1. There you go. And then that was all over g squared, right? So, oh, sorry, not g squared. So you write it out as x minus 3 squared. Okay, so that's my g again. Okay, and then, so the good news is that is our derivative, right? That would be it, but that's messy, right? We don't want to leave it like that. So we will distribute. Okay, so f prime of x would be equal to, and then this will become 1/2 x, and then just remember what you're doing here, right? We're just like adding exponents. So 1 plus negative 1/2, right? Or 1 minus 1/2, so that's 1/2 now. And then on to the next one is minus 3 over 2 x to the negative 1/2. And then minus x to the 1/2, and then plus 1, right? Minus the negative there. And then there you go. So that's a little better. And then that's all over x minus 3 squared. And then we would just collect any like terms that we could, right? Okay, so I'm going to collect my 1/2s. Okay, so this term and this term. So that's really 1/2 minus 1. So that's really going to be negative 1/2. So negative 1/2 x. And you know what I'm going to do right now too? X to the 1/2. I'm going to start turning this back into a radical form just because my original answer or question was in radical form. So I'm going to have my answer in the same form if I can. Okay. So, sorry, I lost my train of thought here. Okay, and then minus, and then I'll rewrite this one as 3 over 2 root x. Okay, just rewriting this guy. And then plus 1. And then that's all over x minus 3 squared. Now, that doesn't look... Okay, so I rewrote this one a little bit different just so you can see the denominators a bit more clearly. Because now what we want to do is we want to put it all over a common denominator, right? In like the numerator part of it. We want to simplify this up. Okay? The top. Okay. So here's what we're going to do. We're going to multiply the first term here. Well, really, it just needs to be multiplied by root x, right? That'd be good. So root x, and then on the bottom, root x, right? That's really what we're doing there. And then I'm going to leave the bottom here as 2 root x, right? Because that's what I like them all to be over. And then for the third term, oh, sorry, and then this should have been plus. I think I erased that, right? Because that was just that. Okay. And then this should have been 2 root x over 2 root x. Okay? So now we can see the denominators there are all the same, right? So now let's just deal with writing out the top. So this would become root x times root x would be just x, right? So negative x, and then minus 3, and then plus 2 root x. And then that would all be over, right, our common denominator there of 2 root x. Okay? And then let's just write it all over x minus 3 squared again. Okay. Now, fraction over a fraction, right? It's really like this divided by the bottom. Dividing by a fraction is the same as multiplying by the reciprocal. So you could flip that all around, but maybe you're getting okay at just recognizing that in this situation, you can think about like both of these guys, this one and this one, as just being in the denominator, right? So let's just write this one more time as negative x minus 3 plus 2 root x over, and then just write them both down here. 2 root x times x minus 3 squared. All right, and then quickly let's just write out our domain here. So the domain would be, so for f of x, we would say x such that x is greater than 0, greater than or equal to 0, and x cannot equal 3, where x is a member of the real numbers. Okay, and just think about where that came from. If we look back up to the original here, that's just from both these things, right? So x can't be 3 because dividing by 0. And it also has to be greater than or equal to 0 because of the square root, right? So that's all that is. And then we'll see that we have the exact same thing for our derivative, which makes sense. Oh, too big. There you go. All right, moving on. All right, so different style now. These ones actually are a little quicker to do because we're going to end up with like an answer, right? So in this case, they give us a bunch of info, right? They say, okay, f of 3 is equal to 4, right? So that would be when x is 3, y is 4 on the original function of f, okay? And it says f prime of 3 is equal to negative 1. So that means when x is 3, y is negative 1 on the derivative graph, right? The slope graph of f. And then g of 3 is equal to 6. G prime 3 is equal to 2. And then they say find f over g prime at 3, right? So this kind of has, it's like a key. It has all of this, the info we need. And it makes a lot more sense if we actually write out our equation for this at 3, right? So let's do that. So we'll say our equation here would be f over g prime at 3 would be equal to, and it would be f prime at 3 times g of 3, right, minus, and then g prime of 3 times f of 3 over, and then g of 3, and then all squared. Okay? So the good news is we actually know what all those numbers are. So we can go back up here and just one by one just check them off. We're like, okay, f prime of 3, well, that's negative 1. Okay, so I'll fill that in. So f prime of 3 is negative 1. And then moving on to the next one, g of 3 is 6. Minus, and then g prime at 3 was 2. And then f of 3 was 4. And then that's all over. And then g of 3, so g of 3 was 6, right? So 6 squared. Okay, and if we do this, we end up getting, so this would be negative 6 minus 8 over 36, which would be, it would simplify down to negative 7 over 18. Next one. Okay, so they kind of show you up here too, right? Whenever you have a quotient function, always check to see if you can simplify the original function before taking the derivative. That kind of goes with what I was saying above, right? You want to see if you can simplify these things down first, because the quotient rule kind of sucks. Right? like what I mean by that is it really adds a lot of extra stuff there. So if we can get away without using it, we should. But sometimes you can't, right? So you have to use it. So let's factor this and see if there's anything magically that'll cancel. So factoring the top here, this would be 2x plus 1 and x minus 8. And then over x minus 8. So they get to cancel like you guys have been doing forever, right? So now we're just really taking the derivative of this simple function, 2x plus 1. Okay, well, what's the derivative of that? So the derivative of f of x would be, okay, well, that's just 2. Man, that was easier. Can you imagine doing all of this, right? You would have ended up with so much. It would have simplified down to 2 in the end, but that would have been hard. Okay, so that's it for that lesson. I'll see you guys in the next one.